very, very interested. Like when we first drove the first car around and you pull up on Starbucks or something and get out, like people would walk up and they just didn't know what to say. They just would be like, what is this? This, my brain can't comprehend what's going on here. Like, this looks like, what is this, right? And you're just like, it's very enjoyable because you're like, okay, well, this is a new idea, right? This is something I haven't seen before. So yeah, to be on a project that really is paradigm shifting is it's incredible.
So today on the Plugged In podcast, we are interviewing Nathan Armstrong. He is the head engineer of Aptera, and it's a very cool electric vehicle company based in California. So right now they have a 3-wheeled electric car. Can you provide a brief overview of what that vehicle is and some of the general uses for it?
The vehicle represents like an ultimate, right? It represents like an attempt at the most efficient use of materials possible to move 2 people around, right? It really is an attempt to establish like a milestone, right? Like an extreme, right? It's not intended as an everyday like Honda Accord replacement, not this vehicle. Right? It goes more down the road that are going to be more kind of traditionally kind of designed and packaged, still using the same ethoses of aerodynamics and lightweighting, which is really the core of the company's whole philosophy. But this vehicle, the first one, really represents the furthest you can take the idea of fuel economy. And it's really intended for anybody who's just an absolute geek, about everything when it comes to intelligent design, right? Intelligent use of materials, intelligent use of form, intelligent use of everything, right? To give you the best result. And what we found, if you approach it like a design project with that kind of a philosophy, is that like there's massive low-hanging fruit in the current crop of vehicle designs, right? I mean, they're all 3,500 pounds north, right? 6,000-7,000 pounds, some of the bigger ones, and aerodynamics of an absolute brick. So no one's really tackled yet the niche of aerodynamics and lightweighting, which to us is an opportunity, but also kind of a crazy situation to find ourselves in. That no one's really looking at these 2 areas as an important place to do work.
So with the Aptera, so what do you see as the main competition for that vehicle? It could be new or used.
The only vehicle that's ever come close, remember the very first Honda Insight? Like the very first one, the aluminum bodied one, right? Like that vehicle is about the closest anyone's ever got, like to the Aptera, right? And I saw the other day somebody put like a Ace Hardware motor in one of those things and got it up to like 60 miles an hour. And it's like 1,800 pounds, right? And beautiful aerodynamics. And then since then, everyone's failed, like horribly with an attempt to do anything efficient, right? There's been examples way back in the 20s. There was attempts, Voisin, some of these guys back in the day did super aerodynamic attempts to try and do stuff. But really, modern day there's really no competition for this vehicle. Like nothing is trying to do what the Aptera is doing.
So with the overall vehicle, you're mentioning the materials that are used to build it. What are some examples of the materials and the overall weight of this vehicle?
The materials, I mean, so it's mostly composite, right? The main body structure is a stress skin monocoque, similar to an aircraft kind of a fuselage. And then it's got a front and rear metal subframe with obviously metal suspension. But the main structure is composite. And there's a few reasons to do this. Primarily form, right? Because the Aptera is such an interesting shape. Most cars on head-on is kind of a square, right? So it makes it easy to stamp things. The Aptera head-on is an ellipse. So you got very interesting challenges with diangles and with different ways of actually forming the panels to make the car. So composites gives us a lot more freedom with tool depth and like different shapes you can make, that kind of stuff. So that was one reason. Second reason is like ramp-up cost when it comes to like production. Composites have a huge advantage in tooling costs and production costs over like metal stamping, right? So that's kind of a no-brainer. But the big one actually is that from the work we did on the very first vehicles when we did the crash testing, we discovered that it's actually a much safer material than metal. The primary reason being that when you compress it, it just returns back to its original shape after you remove the load. So it doesn't. So if you're in a rollover or a collision, it's going to absorb the energy and then just pop back. that's a massive improvement over a current car where it just crumples and crumples and crumples on you, and you end up stuck into a kind of horrible metal kind of a situation where they got to get the jaws of life to get you out, right? Like it's just a not good situation. But composites don't do that; they literally pop back to where they were before, and you can control how much energy they absorb, so you can actually tailor them to do exactly what you want in an impact situation. So we can actually, like, every area of the vehicle is optimized for not only weight but also structural stiffness and impact absorption as well. We're very excited about that because it's literally like the safest car. Like, I've been involved in hundreds of car projects, and this one, I think we were at 6 times the vehicle weight on our initial rollover test, and the spec is 1.5 times vehicle weight. I think it's increased now, but so we were like miles beyond what the specs were for automotive safety standards. So that's very exciting.
Yeah, I that's very interesting. They say that it's, so what's like an example? Because obviously looking at the car, I mean, you don't see a huge crumple zone. So where would the force get absorbed in the vehicle?
I mean, you can think of it kind of similar to just like a massive motorcycle helmet, right? Or, you see the example in Formula One cars a lot where you see the collision and the central composite monocoque tub is still intact, right? Because it does absorb energy so well. But basically the whole vehicle, and the other thing we're trying to do as well, which is a bit more challenging, but we're trying to, we're trying to figure out how you make money, how you make profit as a car company. Building, 10,000 cars a year is still considered low volume, right? And really, to be profitable as a car company, you've got to be way north of that. You've got to be pumping out cars, hundreds a day kind of a thing. So what we're looking at is how you make profit while trying to develop artisan labor, right? Like, how do you make money off of employing artists, essentially, right? Like, how do we create enough value in the project that we can pay a small team but a dedicated team to build these vehicles, right? Because I'm not just doing the same operation over and over again. Like, this is a hand-built vehicle, right? But because we've designed it, there's a big floor panel, which is the basis of the car. There's a structural spider, there's another piece that bonds on, there's 2 sides that bond on, there's many pieces that bond on. And then we fill the whole thing with foam. We inject the whole structure with foam. And then you've got your primary body structure, and after that it goes to the assembly line. But that whole process is essentially hand-built, right? That's like 4 guys, putting the car together like they used to do back in the 40s and 50s, right? Before the robots were introduced, kind of thing. Like, we could automate that process, but it kind of doesn't make sense. Like, we're trying to create jobs. We're trying to create, like, we don't want a jobless factory. Like, that's not the idea here. Like, we want to, we're trying to create work for people. So, and good work, like enjoyable work, like work they can be proud of, right? And one of the kind of the results we want to see with Aptera is that when the vehicle's finished, it looks and feels like a handmade vehicle. It looks and feels like a high-end, tailor-made, like you would get from like a Maybach kind of a thing, or like a Rolls Royce, right? Where you see like these custom touches, and you see the handmade details, and you see that somebody actually put time into making this. You know what I mean? It wasn't just made in a factory. Because we're heading into a future where, like, what do people need? Like, what do people want, right? Like, what do you want in the future? Like, with this crazy situation right now, it really is begged us all to kind of step back and be like, well, what do we need, right? Like, clothing and shelter, right? No food, I guess. Clothing is kind of becoming optional now, right from the bottom down, but it's like, what do we want? And everybody is going towards more, they want stuff that's like, is made for them, you know what I mean? And is special. Like, if you're going to own a car, it should be special, right? It shouldn't just be another one off the factory line. It should be something that was like given attention to and given love to, and it was tailored to you in a way, right? And it has handmade qualities to it, but it's still affordable, right? This is kind of our new paradigm. How do we make that vehicle, but not for $200,000 like a Rolls Royce, but how do we make it for $30,000, right? And the solution to that is in the design and how you design things simply and efficiently, and just minimize part count and blah blah blah, right? But there's ways to approach the vehicle design which is definitely not traditional, which gives us the potential to have an artisan hand-built vehicle, sell it for a reasonable price, and still make money, right? That's the challenge we're in, really. So.
Right. Yeah. No, what I find so amazing about it is that you can get a 1,000-mile range out of a 100-kilowatt battery pack. I mean, that's very impressive. But I guess that comes purely down to the aerodynamics of the car. So in terms of like, would you ever consider, like, say hypothetically, if you were to make one with 4 wheels, right, of the one you have, how much range would you lose from that perspective?
Well, strangely enough, I mean, four wheels, you don't take much of an aerodynamic hit because the rear wheels line up in front of the front wheels, right? So actually, a four-wheel vehicle would be almost as efficient as a three-wheel vehicle. You got a bit more rolling resistance from the other tire, but from a frontal area perspective, it's not much worse. From a regulatory perspective, it's a lot harder for a startup company to do a four-wheel vehicle, right? Again, we're trying to do something here that isn't a traditional car company, right? So raising capital, doing this kind of thing isn't again traditional. Like we're trying to do a whole new thing here, right? But for us to launch with a three-wheel, it gets us into the market and gets the company on its feet, and then we progress to the four-wheeler is the plan, right? But keeping with the same principles of lightweighting and aerodynamics, right? The four-wheeler will be exactly in line as a three-wheeler. It'll be less than 2,000 pounds, right? It'll have a sub, 0.15 CDA, right? It'll it's like, I don't know why everyone else isn't doing this. Like, I don't know why everybody else isn't coming out with lightweight aerodynamic cars. It makes no sense. As we get into the future and lithium mining and battery resources, right? Like I heard the reason the Tesla hasn't made the semi-truck yet is it just can't get enough material to make the batteries, right? So we're literally in a situation where we have a shortage, but then we should be more efficient with the battery materials we do have, right? If you can take the same amount of batteries you put in one car and spread it across 4 cars and get essentially the same mobility out of that same resource, then why isn't everybody doing this, right?
Yeah, because I just think that the tree looks unlike anything else on the road. It's phenomenal. But I mean, personally, I could see kind of some customers being alienated by the tree wheels just from like an aesthetic perspective. I mean, I think it would look just phenomenal with 4 wheels, but it's still awesome as it is, like 100%. So it's great to know that you have a 4-wheel version and down the pipeline that it can still get that awesome range.
Yeah. No, and it's like I say, I mean, the 3-wheel is interesting. It's like I don't mind it. Like once you've driven a 3-wheel vehicle, especially with the front wheel drive, right? And now we've got the in-wheel motors too, which is another interesting dynamic from a vehicle like driver's perspective, right? Like it feels different than a normal vehicle, right? You've got more weight over the tire patch, right? And traditionally you want to get rid of sprung weight. Like that's every engineer's goal, right? Is minimize sprung weight, right? And in our case, we've kind of maximized sprung weight, right? Which is weird, but it puts the force directly over the tire patch, right? So you get a different application of torque, like the torque isn't transmitted to the body. So it's like isolated to the outside of the car. So you get a different feel through the car, but then we can also do torque vectoring between the wheels, right? So like we don't need power steering, let's just accelerate one wheel and the tires will turn, right? So just through like the differential of speed, you can get rid of power steering, right? There goes 50 pounds out of the car, right? So the in-wheel motor thing is very interesting as well, right? And that's going to give us a whole different paradigm in vehicle dynamics and how a 3-wheeler will behave and feel. You can basically change it with the torque vector. It's anyway, so we're excited about that too.
Yeah, I think as well, because there's so few lightweight, like there's no real lightweight electric car at the moment because everything's so heavy with the battery pack. I mean, it's a complete niche. I mean, what I do think will be quite interesting is when the likes of Lotus get into EVs, because obviously they have the Avija, but that's still massive weight. It's a hypercar. It's like well over 1.5 tons. Whereas when they come out with an electric Elise, better than the first gen Tesla Roadster, like even more lightweight. I mean, that will be really interesting, I think, because with the instant torque and everything. So yeah.
Yeah, but why aren't they doing it? I mean, we're basically following Colin Chapman's ethos, right? Like Colin Chapman was like my hero, right? Add lightness and add simplicity. That's kind of what we're trying to do, right? Like the early Lotuses, like the Elise, like the 60s Elise was, I think, the only composite monocoque vehicle like ever made up until like the recent hypercars kind of thing. And Chapman was a genius, right? He was fantastic. But yeah, his philosophy should be carried on through the efficiency now more than ever, right?
So I just have a quick question about the batteries and the cooling. So like on the outside of the vehicle, there's no real sort of defined vents. How do you plan on doing it? Because I was listening to the webinar a few months ago about with Steve and Chris, and they were mentioning how they were going to integrate some sort of body cooling like on the side to cool the batteries. And I was
well, Steve did it. Steve pulled it off. No, Steve's a pilot, right, or an ex-pilot. And skin cooling is something that aircrafts use, pretty commonly, right? Basically, you just bond a loop of coil behind the skin of the vehicle, and if the skin is, thermally transmissive, then you get some cooling effect just through the skin. So on the belly pan of the vehicle, we've got some loops that actually molded into the composite that the cooling runs through. And we're just using skin effect to do the cooling. It's a bigger radiator than you'd normally have, and it's more expensive than a traditional radiator. But again, like the cost isn't the primary driver here; it's efficiency.
So are the battery packs going to be cooled in the Aptera? Like liquid cooled?
Not liquid cooled, yeah.
Okay.
It's
And
all,
then-
yeah, I mean, that's all standard stuff.
And then, so when you were talking about the motors, I was looking on the website and I was like 5.5 seconds in the base model, 0 to 60, and then 3.5 in the dual motor. So could you go into a little bit more detail on the performance of these vehicles?
Well, that's an interesting one because the Alafe, the people that are making the motors for us, they're based in Slovenia. Like they're a remarkable team, and they move so quickly. Like they literally iterate every month or two. They have like a new motor design, and they seem to be right in the phase of development where they're like finding more gains and finding more gains. You know, like as a product develops and you start to see the efficiency gains drop as you get more ultimately efficient with it. Well, they're still in like the bottom 50% of this stuff. They're still like, oh my god, we can we can get this massive gain by doing this. So they're like I don't know where it's going to end. Like I really don't. Like it seems with the current technology of motor controllers, right, which is really the magic of electric cars, right, and don't really get enough attention because the motor is a very simple device, right? The battery is a very simple device, but the controller is infinitely complex, like complexity. You can put anything you want in this thing, and people are stuffing more and more into the controllers than you can possibly imagine. Like these electrical engineers are just going crazy with the features we're seeing in some of these new controllers. And some of the smaller controllers, like for the e-bikes, they're claiming that we can now eliminate hydraulic brakes completely. Like we just don't need them. Like the controller is that good that it can manage that much heat and that much current coming from the motor during regen to basically be able to lock up the wheel and control it to a full stop and not burn itself up, right? And they're tiny. They're like $600. Like it's insane. And like I just can't get into how amazing the controllers are getting, and how rapidly the software is developing. That's going to enable like honestly, I don't know where it's going to end. Like we're seeing drift modes on like the current crop of Lamborghinis and stuff, right? Where it'll put the tail out 20 degrees and hold it at drift for you, right? I mean, that kind of stuff is going to be like child's play, right? Like, what do you want to do, right? You can basically control every aspect of the vehicle through the controller. And what we're excited about too is making it like accessible to people who want to nerd out on the controller. You know what I mean? And like mess with their own car, right? Like, I mean, if you buy a controller aftermarket, you've got full access to the thing. If you buy an electric vehicle, you have no access to the controller, right? And obviously for good reason, because you don't want people really messing with it too much. You know what I mean? A few things you can tweak, but not too much. But if you're an electrical engineer and you really want to nerd out on your electrical car, right? You should be able to have full access to your controller. But why not? Like the worst you can do is make it not work, right? So, you know, and then we can fix that. So it's like, why not kind of take that approach to it? Anyway, the controller is kind of where it's at. We don't know where the performance is going to end. Like we don't know how much power we can pump into these motors yet, because we haven't found the ceiling, right? Like we just don't know. Like, and if you ever played with RC cars, right? So my background, like when I was a kid, was RC cars. So I was used to race them since I was like 7 or 8. And when the lithium motors came out and the the batteries came out and the brushless motors came out, and you built one of these cars, the performance was absolutely mind blistering, right? I mean, you're hitting 80, 90 miles an hour with a 12 scale car. And you're getting there in a second or two. Like the thing just wants to self-destruct. You hit the gas and just literally every bolt in the thing just wants to shake itself loose. Like the power is scaled, but the power you get is retarded. So I shouldn't use that word, but it's crazy. So if you take that same performance and you scale it up to a full-size car, right? You've just got crazy, crazy, crazy limits on what we can do with cars. Like this, it's like I don't know where it's going to end, but like, yeah, it's really, really interesting. It's going to get really frightening. Like we're going to have to just keep dialing it down. It seems like, you know, when we hit the kind of ultimate performance, because it's just going to be too dangerous. Right? So
Yeah, I agree, to be honest, because like from my perspective now, like whenever I'm in a Tesla P100D or performance, call it what you will, in ludicrous mode, and when it goes off 0 to 60, you know, I just find it painful, to be quite honest.
Yeah.
Like, so for me, 0 to 60 time, anything around 4 seconds is more than quick enough, I think. You know,
it's really frightening, right? I mean, in an emergency situation, but I mean, if you want to climb a vertical wall or something, I mean, we're getting to that kind of performance. I mean, it's like the inclimbability and like I don't know, like I love the Model S how it's got the yoke now, the steering yoke.
yeah.
Suggesting it could, you know what I mean? It was like an aircraft kind of thing, like, you know. I mean, where does the performance end with electric? No one really knows yet, right?
Mm.
But like I say, the amount of current we can move now, and the amount of performance that we can get it's getting to the point where the human body just can't tolerate it, right? So
Yeah.
you know,
So when you mentioned the Tesla, for instance, so what do you like, because you're in an EV startup or still in the stages before production, what do you feel about Tesla and how they have changed this industry?
oh, I think they're great. I think the engineering work that you see at Tesla, like have you seen some of the Monroe teardowns? And there's one in particular where they had a HVAC unit, and they had to put a lug in a different place. So they actually 3D printed, like directly on the injection molded piece. So they must have made it a 3D printer that this HVAC unit clicked into, and all this printer's job was to do was to print this little boss for this little clip that they needed, that it wasn't included in the injection tool. And they left it in the car. Like Sandy Monroe was like, look, they 3D printed this piece, right? And you guys, incredible, right? Like that's incredible, right? Like and the thought processes, like you can see the intelligence, like in the car, you can see how people thought about this and they considered this and this was considered. You know what I mean? You can see the intelligence in the design, and that, like to me personally, is like one of the greatest things, because oftentimes in stuff you don't see any intelligence in the design. You just see driven cost savings and and old-fashioned manufacturing techniques.
Yeah, I fully agree. I think Tesla set the bar so high, not with the Roadster, because that was just a lease with a battery shoved underneath, but with the Model S, like that was revolutionary on so many fronts. Back in 2012 as well.
It was beautiful. And the chassis of that thing is beautiful. Like everything on the car is just like so well executed. Yeah, and it really kind of showed the rest of the world how it could be done, right? But they were still trying to, like, they couldn't go too far outside of the norm. You know what I mean? Like, and everyone, you can see that, right? Like, if you want to sell vehicles to the mainstream market, you have to make a mainstream vehicle, which kind of put them in the normal kind of, bad aerodynamics and, 3,500 pound plus. Like, I don't know what a Model S weighs in that now.
I think it's around that, close to, yeah.
I thought it was actually more than that though, but I don't know. But anyway, but I mean, you can take half of that weight out with it and still have a safer vehicle. You know what I mean? Like, but that's not mainstream anymore, right? So, as they kind of like, I think kind of like took something that was mainstream enough, but not mainstream at the same time, and kind of brought it into the mainstream market and changed people's kind of minds on like what they expect of a car and what they see in a car, and like especially like the over-the-air software upgrades. I mean, that they were what people are still trying to do that now, right? I mean,
yeah, and now only the VW group is finally following through with their introducing that in the ID4 and in the Taycan as well. But Tesla,
Tesla. You're not going to get cloud mode. You're not going to get these crazy like Star Wars references and stuff.
It's just a fun car. But I think that's it's quite interesting from your perspective, because then you talk about how Tesla came in, and yet they still kind of want to make it mainstream enough. It was a normal shaped car, just a generic sedan. Yes, it was awesome in so many ways, but whereas the new guys are coming along, you're kind of making it as like futuristic, as cool, as different as possible. So I do think it's quite an interesting perspective, and I think there will be definitely demand for it, because particularly in the US market, I know on the West Coast as well, people want something that stands out.
Exactly. Well, and as Tesla kind of moved something that was kind of sort of mainstream into the mainstream, we're kind of hoping to take these philosophies of lightweighting and aerodynamics and improve safety into the mainstream as well, right? And get people's expectations shifted around as far as what like a car should be able to do, right? And how efficient it needs to be. I mean, I think everyone's kind of waking up to, just using resources more efficiently, right? And I think is it everywhere in the world now by 2035 or 2040 is banned gasoline vehicles?
The vast, I think, just to be Africa, South America, kind of developing nations where they'll still be. But so do you guys have any plans to move over to Europe? Because I'm actually based in Ireland. I was interesting because I saw you had a referral program, and I have 128,000 followers on Instagram. So I was thinking maybe trying to have a go and try and get me a Aptera, So I was wondering, do you guys have any plans to expand to Europe? Like, I know US is your primary focus initially, but long term, what's the story?
There's definitely plans to try and get as much around the world as we can, kind of thing. So yeah, I think there is some Europe has different regulatory issues than North America, and they're a lot stricter in some respects. So there might be a little bit of I don't know yet, right? Exactly how we're going to be seen by the DOTs, essentially the European automotive agencies, like how they're going to perceive the Aptera as something that they want to see on the roads or not. Like we haven't really crossed that bridge yet, but it really comes down to if there's demand and people get that it's like kind of the right way to go, right? Then we'll probably see more government assistance in getting the vehicles over there. You know what I mean? Because it isn't a mainstream vehicle, like it is a fairly large three-wheeler, right? So it doesn't fit in everybody's categories of what what a vehicle is, right? So in North America, we have this autocycle category, but it fits into quite nicely. But Europe doesn't have the same category exactly, or it's a lot closer defined. Each category is a lot more strict. So you have to find out which category we can slot into. We might have to bend the edges a little bit, but we're definitely trying to get over there. Yeah.
Yeah, I mean, definitely. The second largest EV market after China. So, it's be huge. And I can definitely see an appetite for it here, to be honest.
Well, a lot of people over there too that are interested in efficiency and interested in good design and unique design. And, and one of the things about the Aptera too, that, you see it in person, like it's just beautiful, right? Like when we first put the first car together, like everyone just stood back and was like breathless. It was like, wow, this is beautiful, right? Like it really is a gorgeous car. So Europeans' taste generally tends to be a little more refined when it comes to like design, that kind of stuff. Like vehicles in Europe are they're 5 years ahead of the vehicle designs in North America. When we look at the stuff over there, like the Alpine, right? We're like, oh, come on, they won't bring it to North America, right? I mean, that's the car I would drive, right? If I couldn't have an Aptera, it'd be the A110. Like that is just a phenomenal car. But we don't get them over here, right? So.
Yeah, funnily enough, my dad was actually looking at an A110 not too long ago, so we're not quite sure yet. But yeah, they're a gorgeous car, 100%. Yeah.
Again, another example of a car that's kind of like hand built in limited numbers, right? Like the construction of that car.
Oh yeah, for sure.
Was very clever, right?
Funded through Renault, but Alpine, separate brand, technically subsidiary, and it was just very limited numbers. I'm not quite sure the production run at the moment. They're still making them, I believe, but yeah, no, it's gorgeous.
Yeah, and is it composite top or is it aluminum top on that one? I forget. But it's a very simple car again to build, right? But the very first Alpine 110 was an interesting story too, if you know that one. That was one of the first cars that was licensed.
Back in the 70s and 80s, kind of big and rally.
It was built in something like 17 or 18 different factories around the world. Like he licenses to different countries, and they would basically build the car in different factories. And they send them the bits, and they would do the composite parts there, and then they would build them locally. Like it was one of the first ones to really kind of suggest that cars could be built in more of a local market kind of thing, right? And one of the things out there we're looking at too is the use of natural materials. So I've been involved in like natural, like plant-based composite research for like probably 15 years now. And it's getting quite interesting on that front too. Like we've got hemp fiber composites now that we're doing. We've figured out how to make it into a traditional composite type manufacturing system. So we have a 2x2 twill natural fiber mat that looks and performs just like fiberglass, right? And it looks like it outperforms it in some ways, right? So we're just in the testing of this now. We don't know when we're going to bring it into like production vehicles kind of thing. There's some obviously like flammability, this kind of stuff we got to get through, certification stuff we got to get through. But we're actually looking at a possible situation. Like we found a resin in Europe, and it's very expensive, and it's a heat form process. But they claim that it acts like an epoxy, right, for its entire life. And epoxy is the strongest fiberglass resin you can get. You've got epoxy, vinyl ester, polyester, right? But epoxy is like top of the line. That's like aircraft, marine, all the good stuff uses epoxy. So it acts like epoxy when it's above ground, but as soon as you bury it, it biodegrades, like down to nothing. It's like 99% plant-based, but yet the performance is like an epoxy, right? So if you mix that with a natural fiber mat, and then you've got the promise of a material that acts like fiberglass for its entire life until you bury it, and then it biodegrades. So like that is revolutionary. That's revolutionary. Like no one's ever been able to do that before, right? And if you're growing the material from plants, right, that means you can do it more locally, right? Like you can grow hemp anywhere in the world, right? So, you know, the future, like when these opportunities start coming together and you start saying, we put this piece and this piece and this piece together, and all of a sudden this opportunity kind of presents itself, and you go, ah, like this is really incredible. Like this is mind-blowingly incredible that we can have an entire car, right, made out of natural materials that is biodegradable, but has like incredible performance when it's in use, like that. Like I couldn't even perceive 5 years ago that that could even be a possible future like scenario. Right?
That would be incredible, to be honest, because that's the issue at the moment. Like there's still like the climate damage in terms of producing the car to begin with, even if it's sustainable. And then of course, when you're disposing of it, like the battery per se, like that's the main issue as well. I get questions every day. People are like, oh, how's an electric car friendly if you still have to dispose of the battery at the end of its life cycle? So,
but as we're seeing with Tesla too, though, they keep the batteries so they got some useful life left and use them for stationary storage, right? I mean, that's the best thing to do with batteries, right?
that was a smart policy increase, yeah.
Yeah, but you obviously haven't need enough useful life at the end that they can use them for that, right? You can't wear them out. But yeah, anyway, so that's kind of where we're going. But like that's an incredible vision for the future. Like to me, is like that's like an all natural, like I say too, like in the production of fiberglass and especially the production of carbon fiber. Like it's a horrible process, like environmentally, like it's carbon fiber is one of the worst things you can make. You know, it's an amazing material and we don't use too much of it in the car, but it's like it's toxic, like it's horrible. And a natural fiber composite basically is like no toxins, especially for the workers as well, which is a big deal. And it's using like turn of the century technology. Like we're expecting almost like the weavers to turn up and burn down the powered loom, burn down the powered loom like they did back in the day, right? Because they're taking jobs away for the weavers again. Like we're kind of back in that kind of a situation. So history is kind of repeating itself a little bit here, but in like a new like kind of a way with much higher performance, you know, end result kind of thing. So, so very excited about that kind of side of things. I think that's going to be a huge deal for us.
So going back to the motors, and I was just wondering, like, because a lot of electric cars actually do need cooling for the motors. How do you plan on cooling the inboard motors on the front wheels?
Yep, they're liquid cooled.
Liquid cooled through like how do you manage to do that? Like through the obviously through the axle or some sort of
through the upper wishbone, we've got
the wishbone, right?
Because there's three big old cables coming out for the actual drive, and then there's two cooling lines and then a data line. They'll chuck up over the wishbone and get hidden in the well.
So is the battery and the motors on the same system? The cooling system?
Not two systems. No.
Okay.
But really, I mean, what we're finding with either is that they don't require a lot of cooling.
Right.
I mean, heat is a byproduct of inefficiency, right? So when you start running things more efficiently, again, the controller does a lot of this work. You find that things don't need a lot of cooling. So it's only extreme situations like heavy braking or something like that where you might get a lot of heat soak kind of a situation going on. You got to move out of there, but otherwise they don't run hot at all. Like they run nice and cool.
So when you're talking about all these sustainable materials in the vehicle, there was another vehicle made, debuted in 2013, the BMW i3, which featured recycled materials to be built, except it has four wheels. And I do see some parallels with them. Do you see any as well?
Yeah, they used that on the top of the dashboard, didn't they? On the top of the IP, they had I think it was a flax panel.
I think they had eucalyptus wood as well.
Yeah. I don't think it was used structurally though. Right, I think that's where we're kind of maybe deviating. Like the Lotus did the Eco Elise back in like 2014 as well, where they made a body out of hemp. And then of course you got Henry Ford's famous like 1935 car that he made out of hemp. But that was all the non-woven, right? So when you process hemp or any kind of natural fiber, you end up with kind of just a mat, right? It's like a shredded wheat kind of looks like a guy's ugly beard, right? And it doesn't have very good performance characteristics. But if you actually can weave it like a regular composite, you get much better performance. And that's what we've done, right? So I think every natural fiber car built to this point was using a non-woven material, right? I think the flax in the BMW was woven, but it wasn't used for anything structural. It was just a dashboard pad, I believe, right?
Yeah, sorry about that. I thought you were talking, because the frame of it's made out of carbon fiber reinforced plastic. And
it's carbon fiber, yeah.
So what was the decision? Because you said there's no carbon fiber in the Aptera, is that correct?
we don't need it. There's no, because fiberglass actually flexes better. If you look like the 787, like the big aircraft, the fuselage is carbon fiber, the wings are carbon fiber, but the part that connects the wings and the fuselage is fiberglass, because that's where you get the most flexure, right? So fiberglass actually has better characteristics in flexing than carbon fiber. It's much better environmentally to produce. And we don't need the performance of carbon fiber, like we're not going for race car stuff here. And carbon fiber tends to shatter as well, whereas fiberglass tends to absorb more energy. So, fiberglass for us.
As you said, the production of carbon fiber is much less eco-friendly too on that front. So,
yeah, once you've been to a carbon fiber factory, you go, wow, like, wow, this is horrible, right? Like horrible. But as we get into the natural fiber stuff, like we want to try and be replacing the like the fiberglass materials, right? But like that's way down the road kind of thing. Like we've got to categorize these things first of all for stuff like interior panels and stuff like non-structural panels before we move into anything structural or semi-structural, right? But the initial tests are showing that we should be able to like it's crazy to even say like meet the same performance like characteristics as fiberglass, right? I mean it's so we're very excited about that. Like that really is to us like a massive breakthrough.
Yeah, so on a slightly different note, because I use the i3 comparison, I think that was a little unfair for one reason, because the i3 is really expensive, brand new. And this Aptera is going to start at under 30,000 US dollars. And the performance you get with that and all the stuff is pretty impressive. So what was the purpose of this low price point? Because it could have easily been more money than that, because you're getting a pretty decent value for the price.
No, I know it's an interesting market, isn't it too, right? I mean, when we bought the very first car out, I think it was the same kind of thing. They were saying 35,000, and I think a bunch of us were like, you could sell this for like 90,000. You could sell this for like 120,000, right? Like, I mean, what's the price point on this thing, right? Like, what is really the because when you see it, you're like, wow, right? Like if this had hand leather stitched interior, like if it looked like a Rolls Royce inside, you'd think it was a $120,000 car, right? You really would. This is incredible. But the idea that we want to try and spread, it's like the Model 3, right? You want to try and get the idea and the philosophy out around lightweighting and aerodynamics, right, to as many people as possible, right? And again, it's a strange, like these added benefits pop up in interesting places, right? So because the body is so simple, like it actually doesn't fundamentally cost a lot to make, right? Like this is one of the things we ran into. It's like, well, like we actually don't need to charge too much for this car because it doesn't actually cost that much, right? And the ramp up and the tooling costs. So like if you buy a car right now, you're paying for the amortization of the tooling in the cost of that vehicle, right? So like a normal car is say 100 million, right, to 200 million to tool up, right? Well, they split that in the cost of each car, and then that gets added to the price of the car. The famous story of the Ford Taurus, remember the like oval window Ford Taurus back in the 90s? I think they started making it in the early 2000s. The one they made for like 20 years. The story was at the end of its life, that car cost $500 for Ford to manufacture because the tooling had been paid off for so long. Like everything had been paid off. They just were literally just making the cars. So it's $500 per car was their cost, right? Which demonstrates like what a car actually costs to make. Like once you pay for the tooling, they're not actually that expensive, right? And because the Aptera is cheap, not cheap, but they're simple in its construction. Like we don't have, like the i3 was beautiful, right? But I mean, if you saw the video of how the chassis went together, they made all these carbon fiber pieces, and there's a whole fixtures that bonded all these things together. And there's a whole assembly line just to manufacture the primary like CRP structure. But we get that in 4 pieces. They just bond and they all self-locate, and then off you go, right? So our design approach is radically different than anyone else has done in that respect. But yeah, like, but yeah. So it's just working out really well. Like once you embrace efficiency, you end up with a lower cost to produce product, right? It's just one of the things that happens. So why not roll with it? Like why not pass that saving on to the people? Like why, right? Why try and be greedy? Like it doesn't make any sense. So.
Yeah, I think like that would be so good for your brand to be able to produce like and make it a profit from the start. Because you look at Tesla, I think it took them 8 years or something like that to actually make their first profit on a car, and then it turned out they were losing money for a while. Now they're making it again. It's kind of so like, yeah, again, like I guess it's really worth exploring these areas to have a look at these materials and then reduce the costs in turn.
Well, just be more intelligent in how you approach car design, right? Like think more like Colin Chapman, like think blank page, right? Don't think like legacy, right? Like cars are the way they are now because the complexity has increased over the years, and they're the size they are now because they keep getting bigger. Because the when you inherit a car program, you do the next rev on it. You're going to do the facelift on the new engineering team. You can't go smaller because everything's already set on the hard point, so you end up going bigger. So cars just keep growing over the years, right? And it almost needs to be like, oh, hit the brakes, guys. Like, can we just stop? Like, why are we doing this now, right? Like, we're making the cars the same way since the 50s, right? Stamped steel, spot welded, you know what I mean? And even the new crop of Mercedes and like the beautiful like Audis that are coming out, they use multi-use material, and they've got carbon fiber, and they've got aluminum, they've got high strength steel and regular steel, and they bundle this together in a big, unibody kind of a thing. Like the sheer complexity of that is mind bending, right? It's absolutely mind bending. We can achieve the same thing with a much simpler design, right? Like what is the goal, right? We're looking for efficiency and safety. Right? So no, I think it's I think it's time for these kind of ideas to come to the forefront. I think it's time for Aptera to kind of show the world that, like, we can do much better, like in how we design things than what we've been doing, right? But it's going to take a radical approach to, kind of bring this idea forward, right? And this is kind of what this vehicle is really intended to do.
So talking about going bigger, like we know that the Aptera paradigm is only 2-seater. Is there any talks about creating a 4-seater or some sort of larger vehicle for the future? Because obviously a 2-seater isn't the most practical for most families. So just out of curiosity there.
Yeah. I mean, it's publicly known. There's pictures of a 4-wheeler out there that we put out there years ago. So you've always wanted to do a 4-wheeler. It's obviously more expensive to get into the market, right? So for a startup, it's a 3-wheeler is the quickest way to get to a saleable vehicle. So really, it's about time to market at this point. But once this vehicle is out there and again is like really set the benchmark for what efficiency means, right? Then from that point we can grow, right? So, but I mean, a 4-wheel vehicle using the same design philosophy as the paradigm would have similar characteristics. It would be sub 2,000 pounds. It would be, ultra aerodynamic and ultra safe. I mean, that would be.
Yeah, I was talking about a 4-seater.
That would be 4-seater, yeah.
Yeah, 4-seater, yeah.
But take anything and use these same like philosophy ideas behind it, right? Like take it a second, right? Take anything. No one really has used good principles on aerodynamics, like almost since the turn of the century. I forget his name. He was a French engineer, like 1910 kind of time, who was really big into aerodynamics. He was an aircraft guy. And then really since then, it's kind of been ignored, right? His work was largely ignored. And then since then, it's almost been ignored. It's been around, it's been cost-driven design, right? So vehicles are basically designed to be the cheapest to make, not necessarily the most efficient, right? So, again, taking a different approach to that. So.
Yeah, and talking about the aerodynamics, I think that's something very interesting to mention, because even some of these like fuel efficient vehicles like the Toyota Prius or the Chevy Volt, because I drive one of those, and it's just the drag coefficients are just not that great on them. I mean, you look at the Tesla Model S, which is way bigger, way heavier. I mean, weight doesn't matter as much, but design. And it's like this Prius, which you would think would be such a aerodynamic cars, like 0.27 CD, where Model S is under 0.21. And it's just, it's very interesting. And being a 3-wheeled vehicle, you can, I'd assume it would be able, or especially with the, at least a front of design, because it's similar to an aircraft. Isn't it like 0.13 or something around there?
Yeah. We were at 0.09 at one point.
Wow.
But it was impractically small on the interior. So we had to bump up a little bit, but yeah, we're still like and it's like, like anybody's put their hand out of a car window, you know what I mean? Like, and felt the resistance. Like I have a 1952 MG, and it has a flip up windshield, and the thing's only like 45 horsepower, 50 horsepower, right? And you flip the windshield down, all of a sudden it's like a whole new car, right? You flip the windshield up, and now you got this piece like this in front of the window, and the drag on that, you can actually like feel the car slow down, right? So like the practical, like it's not difficult to figure out, right? Just like drag on a car is the biggest loss, and they all suck. Like they're all terrible. they're all terrible. We only went halfway as far as efficiency when it comes to aerodynamics, right? And why stop? Like, why not? Right? I don't know.
All right, so it's getting close to the 2 o'clock here in Charlotte, North Carolina, and we usually try to keep these under an hour. And before we end this, I'd like to ask one question. When do you see production starting of the Aptera?
Oh, it's happening now. It's
Ooh.
it's scrambling now. I mean, we're not like production models yet. There's we're going through the last kind of like engineering changes before we start doing the pre-production builds, and then so we're currently making the current design vehicle as fast as we can, just to get as much testing, as many vehicles on the road as we can. Some engineering rework. There's a whole production team working on factory layout and supply chain management stuff now, and we're going to start building pre-production vehicles early summer, and then getting through, you know, initial kind of just shakedown and initial testing, and real certification testing starts and that kind of stuff, kind of in the summer, and then towards the end of the year, we're hopefully going to be getting the first units out the door, kind of thing. So we're going to go as fast as we can, and the goal is to deliver this year, right? So, but there's going to be a lot of work between now and then. Obviously, they're not going to be like the heat pump kind of things, right? Like that's not going to happen this year. Like there's way too much engineering and development work and that kind of thing. So there'll be improvements as we kind of build out from this year. But obviously, we're designing everything to be forwards and backwards compatible. So if you buy one of the early cars and the heat pump system comes out, you can just have it retrofit back in, right? So we want all these cars to be upgradable, like infinitely kind of thing, you know, software and hardware wise, right? So yeah, we're hoping this year to start seeing some of the new ones come out, and then you'll see the new body design come out in the next month or two. It looks fundamentally the same. It's a little bit longer and just a little bit bigger all around to give us more interior room, but it's still as beautiful, and we're all quite pleased with how it's turned out. So, yeah.
Sounds like very exciting times.
It is. It's very interesting. Yeah, it's interesting, and you know, it's interesting when you try and change people's minds about what you know, they perceive as what a thing should be, right? Like, and that's always an interesting time. Like that time of transition is always you know, how people respond and what they say and what they come back with and their reaction. Like it's very, very interesting. Like when we first drove the first car around and you pull up on Starbucks or something and get out, like people would walk up and they just didn't know what to say. They just would be like, what is this? You know, my brain can't comprehend what's going on here. Like, this looks like, what is this? Right. And you're just like, it's very enjoyable because you're like, okay, well, this is a new idea, right? This is something you haven't seen before. So yeah, to be on a project that really is paradigm shifting is you know, is incredible. And like I said, if you guys want to get more involved, you want to join the team, like whatever, I mean, like we're always looking for you know, people to join the family kind of thing, right? Like this really is a human company. Like we want to be about people and, you know, people's experiences, right? So